Hi, my name is Lauri Himanen and I'm a part of the NOMAD development team. In this video I'm going to give you a general introduction to the NOMAD Encyclopedia, which is used for exploring the NOMAD data in terms of materials. You will gain a basic understanding on how the encyclopedia complements the other NOMAD services and which tools we provide for accessing this materials information. The NOMAD archive and repository are organized in terms of uploads, calculations, and datasets. Users upload their raw data from which individual calculations are automatically detected. Calculations can also optionally be grouped into datasets and given a DOI. Other users can then search the individual calculations or datasets in terms of the used method, calculated properties, or the involved chemistry. However, the focus of materials research is often on specific materials. A material may, for example, be a specific well-defined crystal structure, a certain two-dimensional material, or a one-dimensional polymer. The atomistic representation for a particular material can vary, as the choice of the unit cell axis and lattice constants may be different, the system may be rotated or repeated periodically, and typically there are small deviations in the atomic coordinates. Without any additional processing, it becomes very difficult for a user to target a specific material in their search. The goal of the NOMAD Encyclopedia is thus to organize and provide access to the NOMAD data in terms of materials. The first task in building this new layer of materials information is to assign a material for each individual calculation. The methods for this material identification will be discussed in more detail in the next video. The end result of the material detection is a material identifier that is assigned to each calculation from which a material could be successfully detected. This material ID forms the basis for the NOMAD Encyclopedia, and it adds an additional layer for accessing the data stored within NOMAD. In addition to grouping materials data within NOMAD, the material identification also provides means for linking external material information to the encyclopedia. Let's take a quick tour at how you can explore this materials data in practice. Currently, we provide a dedicated graphical user interface for browsing materials. This interface can be accessed from the NOMAD Lab website, and it uses the same data that is stored in the NOMAD repository and archive. The search options are divided into three categories. You can search materials by selecting specific elements in the Element tab, search with a particular chemical formula or a material name in the second tab, or narrow down the search by specific properties of the structure, specific physical properties, or the used computational method. After selecting suitable search criteria, you can perform the query to view the results. In the list, each individual entry is a separate material, and you can view some initial details about them with a quick glance to select the one you are interested in. Selecting a specific material brings you to the overview page, which summarizes the results for this material. The overview page is divided into separate sections for structure, methodology, electronic structure, and vibrational and thermal properties. Each of these sections can be expanded to view more details. From the structure section, you can find a summary of the symmetry properties of the structure, together with a quick overview about the distribution of lattice constants, volumes, and densities, grouped by the used functional. You can also explore individual calculations and groups of calculations from the calculation tree. The methodology section shows a quick rundown of the functional families and codes that have been employed in the calculations for this material. Going to the dedicated methodology page, you can view all the individual calculations, together with a link to the respective entry in the archive. The electronic structure section shows a representative band structure and DOS, together with a drop-down menu for similar materials based on the density of states. From the electronic structure page, you can explore all the band structure and density of states data, also ordered hierarchically by the functional family and code. Whenever vibrational and thermal properties are available for the material, they can also be browsed individually in their own page. There you can access results for phonon dispersions, specific heats, and free energies. The graphical user interface is powered by the Encyclopedia API that can be used to access the data programmatically. Use of the graphical interface and the API will be covered in the hands-on exercises. To summarize, the NOMAD Encyclopedia complements the other NOMAD services by gathering materials information across all users, methods, and calculated properties. This new layer of materials information increases the findability and accessibility of the data stored by NOMAD. We are constantly improving the encyclopedia, and you can look forward to our future progress. In the next videos, I will discuss the techniques behind material identification and give hands-on tutorials on using the graphical user interface and the API.